This is your Tiny Coder back again with another coding session. So this session, we'll talk about a thing called a Raspberry Pi. So what is a Raspberry Pi? Well, so a Raspberry Pi is basically an IoT board, and IoT stands for Internet of Things. So with Raspberry Pi, we can make a lot of devices and we can also automate them. So some examples are like Google Nest. So Google Nest uses a very advanced IoT board, and Raspberry Pi is actually a very fundamental IoT board. And also another example is Ring. Ring also uses more of an advanced IoT board compared to Raspberry Pi. So you can see all these devices or IoT boards actually have more advanced features compared to Raspberry Pi. Raspberry Pi is a very fundamental IoT board. So this is how a Raspberry Pi looks like here. And then this thing over here is the Broadcom BCM2835. And then here there's a run header. Then there's 4 mounting holes here. And then there's a LAN which is related to Wi-Fi here. And here it has a display connector right there. And then it has a micro SD card slot which is underneath this thing. And the micro SD card is actually the most important thing in your Raspberry Pi, because all your RAM, all your memory, and all your operating system all depends on your micro SD card. And then here it has a switching regulator, so then it consumes less power. And it also has a lot of computer-like features, like 2 USB ports, an Ethernet output, a composite output jack, a camera connector, an HDMI output, and a 5 volts micro USB power, which is kind of like the charger that we have. And here there's 40 GPIO headers, so we're going to discuss more about that in our next slide. So these white holes are basically what we saw in our last slide, and this is just a close look into it and all their pins. So this is what we call the pinout. But before we go on to all of this, what is GPIO? Well, so GPIO stands for General Purpose Input Output. So using these things, which are called GPIO pins, we can make a lot of our circuits. And there are also special GPIO pins, like you can see this thing, which is the clock pin. So this has a very special use case, which is the clock. And here there's a 5 volts power pin, a ground pin, which is kind of like the negative terminal always. And then it also has a lot of general purpose GPIO pins, which don't really have a special purpose, but you can use it your own way. And some examples are like GPR23. So those are just some examples. So today we're going to learn about LEDs in Raspberry Pi. So first of all, we have to know the circuit for it, right? But some examples of LED projects are like a traffic light, right? You can have one LED as one traffic light signal, and you can have another LED as another traffic light signal. But before that, we need to know its circuit. So this is the circuit for the LED. So you can see here's the Raspberry Pi, and here's the circuit, which I'll explain later. But what is this? What is this thing around it? Well, that is what we call the breadboard. So you can see that the breadboard has some holes here. So these holes over here in the circuit area are all connected vertically. They're connected from up to down like this. And then between this blue and the red are what we call the power rails. So that is where we get all of our power supply from. And then, however, they are not connected vertically, but they are connected horizontally from left to right, like this. They're connected from left to right. And then this is the circuit of it. So you can see that one leg goes to this blue wire, and you can't really see it, but it goes to GPIO21. And then there's another wire which goes through this resistor, which ends up going through this red wire, which ends up going to ground. So that's what the circuit basically is over here. And if you look at an LED in some way, then you can see that one of the legs is longer than the other. So how do we identify them, and how do we put them on correctly in the circuit? Well, so the longer leg is what we call the anode, and the shorter leg is what we call the cathode. So the longer leg, the anode, is usually supposed to go to GPIO, and the shorter leg, the cathode, is usually supposed to go through a resistor, which ends up going to ground. And you can already see that this goes to GPIO, so that's the anode, and this goes to a resistor, which ends up going to ground, so that's the cathode. So now let's make the traffic light signal project as I explained to you guys earlier. So I'll just I've already done my remote desktop connection here, and I will just zoom this in so then we can see this project properly. So you can already see that there's a yellow LED and a yellow car and a red car here, and then there's a green car here, and there's a blue car here. So these are on the vertical axis, the north and south, and these are on the horizontal axis, the west and east. So I'll just show you how the LEDs are first of all, how I organize them. So I'll just resize them, and here I'll bring up my phone. So it will come in a moment. You just wait for a second. Come here. Okay, so this is the phone you can see already, and here there's a west to east over here. There's a paper, so that's basically this red LED and this green LED, and then there's a north and south over there, that paper, and that is basically this red LED and this green LED. So you can already see that this relates to the traffic light signal that I had, and I'll just say always on top there. So I'll just go back here and maximize that so we can see it more. So I'm gonna keep it to the side so you guys can, so then we can also see the cars animating, and I'll also run my program there. So you can see that first this yellow and red cars are gliding from the west to east, and you can see the LED for that is green, and that's why they're gliding and moving. And then the green and the blue cars are not moving because they're on the north and south, and you can see that they currently have a red signal, so that's why they're not going to move. And then they're just going to keep on gliding for 5 times, and then after that these two will start going. Now you can see it's the opposite. So now the green and the blue cars are gliding, and you can see that they also have a green signal there. And then the west and east cars are actually not gliding because they have a red signal here. So this will just go on for a moment, and then after that it will be vice versa. And that's just my traffic light signal program. So they'll just keep on animating for a moment. And now you can see that they're just going to do this all over again. So that's how my traffic lights project is. So I'll stop my program, and now let's make this. So I'll exit that, and I'll exit the Scratch 2 window, and then I'll open a new Scratch 2, programming, Scratch 2, and I'll maximize that. There, okay, good. So I already have a ready-made template for that, so I'm just gonna load that project. Yes, replace the contents. Okay, good. So now let's program this. First, I'll just uncheck that and come here. Okay, so I'll first just maximize this so you guys can see the code properly whenever I show it to you guys. And just a little more maximizing. There, so now it's max. So I'll just do the first block, which is the when green flag clicked. Keep that there. And first, we will just go to the position that they were before. So just motion, go to here. That's just where they'll go. And I'll do the same with all the others. So I'll just say when green flag clicked, motion, and I'll say go to here. So they're just going to their X and Y positions currently, and then after that we're gonna make the animation of it, and then also we'll do our GPIO. So I'll just say motion. Okay, that's great. And the last one. Okay, so it's here, and I'll just go here. Okay, great. So that's done. Now we just have to first make these guys glide, but they're gonna continuously just keep on gliding. It's first that these two will glide, and then these two will go, and that'll just go on forever. So I'll first create a variable. So I'll go to data, make a variable, and the variable name will be, let's say, horizontal axis. Okay, so I've made that variable. So initially we're gonna set that to false, actually, or we're gonna set it to true initially. We're gonna set that to true because they are gonna glide first in the project, and then these two will start gliding. So I'll keep that there, and then I'll have I'll just wait for 1 second when they start. So I'll just say wait 1 second here. Good. So there you go. So now forever, I'll drag this forever block here. If the horizontal axis is true, then these guys will glide. So I'll say if, and then go to operators, take equals block, and then I'll drag in the horizontal axis. If the horizontal axis is equal to true, then I'm gonna make these guys glide, but they're gonna just keep on going back and forth 5 times. So I'll go to control and just say repeat block. So repeat. And instead of keeping it 10, I'll keep it 5, so then it doesn't take as much time. And then I'll first say glide, so I'll say motion, and I'll just drag my yellow car there, and its Y position should be the same, but its X position should be different. So then I'll just say glide 1 second to X position here and Y position there. Instead, I'll change this for 5 seconds, just so that then they don't go too fast. This is supposed to remain minus 62, by the way. And then I'll keep this as 350 as an example. There, great. So that's done. Then after that, what I'll do is just say go. I'll just make them go back to where they were. So I'll just take another go to block and keep it there. So I'll just keep it basically as the first block here. So this is going to be X position minus 101, and then I'll say minus 62. So they're just gonna go back to their initial positions, and that's all they'll do actually. And then after they're done, we're going to set horizontal axis to false, and that's what we'll do. So I'll just go to data, and I'll say set. Once I set horizontal axis to false here, false. There. Okay. So then we're setting it to false because then these two will start gliding, and I'm gonna do the same thing here as well. So I'll just say go back here. So we don't have to really set any variables. Just say wait 1 second, and we're gonna do the exact same commands as that. So I'll just say, I'll just right click and duplicate that, and then I'll drag that in here in the card too. Okay, good, so it's here. So I'll attach that. Then it's not gonna glide to the same position as the yellow car, so that's why I'm gonna change this. I'll bring it somewhere here and see the position. Okay, good. So currently it is, let's see the X position it has. So currently it has minus 210, but we want it to glide a little more. So I'll just say for example 5 seconds to X minus 250, and I'll say Y. I'll say minus 2, but we have 4 as our initial one. You can already see that here. So I'll say 4. Good. So that's what it is, and then it's gonna go back to its initial position here. So I'll just say change that, and I'll keep it 194, and this will remain 4. There you go. So that's what it is, and it's already setting the horizontal axis to false, so we don't have to worry about that. And that's all actually. So that's our code for here. So now let's just run it and check how it goes on. So no. So I'll just run it. So you can see that they're gliding. So that's once, that's twice, and they're gonna glide again. That's 3 times, 4 times, and the 5th time, and they stop. So that's what they were supposed to do actually. And then these two will start. So that's what we're gonna do for them as well. So I'll just go here, and we're gonna do the same thing, but it's gonna be a slightly different program in our case. So we're just gonna say data, and we're gonna make a new variable called it's gonna be called vertical axis. Vertical axis. Okay, create it. Good. So currently I'll set my vertical axis to false. So here I'm setting it to false, and now we're gonna wait until these two cars have stopped gliding, and then only we're gonna make these two glide. So I'm gonna say control, and I'm going to say wait until. So today we're gonna use the wait until block here. I'll say wait until, go to operators, and say wait until, and I'll drag that. Wait until the horizontal axis is equal to false, because it's currently set to true whenever these two glide. So if the horizontal axis is set to false, which means that after these two are done gliding, then only these two will start gliding, the ones on the north and south axis. So say wait until horizontal axis is equal to false. And then after that, I'll say go. So then after that's done, then we're going to have the same forever condition that we had, and we're just going to make them glide in different ways. In this case, the x position is supposed to stay the same, but the y position is supposed to change in our case. So just say if I'll say if the vertical axis is equal to true. So here I'll say data vertical axis is equal to false. Or sorry, no. This is supposed to be true. If vertical axis is true. So after that is done, the vertical axis is true because these two will glide. So I'll just keep it true. There. Then again, the repeat 5 times as we had earlier. Repeat until. Or sorry, no, it's not repeat until. It's repeat 10. So I'll keep it 5. And then I'm gonna make these two glide again. So I'll just take the motion, and I'm gonna change its y position here. So I'll change that a little more. Okay, good. So I'll take this glide block here. So its x position is currently 53 and minus 100 in that. So is that the green? So its x position is originally supposed to stay the same, but the y position is supposed to change. You can see a big difference between that. So I'll change this to 54, and here instead of keeping it that, I'll say minus 200, for example. And then after that, we're gonna make it go back to its initial position, which is the same as that. So I'll keep that here, and x position 54. Y position 106. Great, so that's what they're doing. And after that's done, then we're supposed to set the horizontal axis to true. So then they will start gliding. So I'll say data set vertical axis to false. And then we're supposed to set the horizontal axis to true again, because these two are supposed to start gliding again. Again, as you know, it goes on forever. So everything just relies on this if condition here. So it's outside this. So everything relies on this forever. So whatever is inside that is what the whole script will be. So that's why these two are supposed to go, and then these two will go, and that's how it will just go on forever. So that's why our whole script is just supposed to be there. So that's why I'll just say set horizontal axis to true. So then the other guys start gliding. So I'll say set horizontal axis to true. And that's all actually. So I'll just duplicate that. I'll just duplicate this thing. And I'll keep it in the car 4. So we can kind of detach these, and I can keep that there. Keep it here, we don't need this. So great. Now we just have to change this, keep that out. And now this has different glide positions, so that's also different. We can, so for that, what we're gonna do is have different X and Y positions. So currently it's 126 and Y is minus 248. So I'm gonna make it go higher. Okay, good. So if I go to motion and see, it's X 129, but it's supposed to be the same. So I'll change the X to 126. 126, I'll just delete that part. 126. And then the Y is 44. So let's just make it 50 in our case. 50. And that's where the car is gonna glide. And then it says go, and then it's gonna go back to its original X position and Y position, which is 126 and minus 248. So that's going to be 126. And this is going to be minus 248. So whenever we do our main script, meaning that whenever we do the final time, then we're only going to see it once. But mainly, that's not what we're supposed to do. We're just debugging, so we'll see it twice. So let me just run this. So these two are going. I'll just start it again. So these two are gliding. And oh, we should change this to 5 seconds. You saw that whenever we ran it first, it was going really fast. Fine, good. There, good. So they're going once, twice, 3 times, 4 times, and then it's gonna be the last one, so that's the 5th time. Good. So now these two are starting to go. So let's calculate there. So that's once, twice, and then it's going to be 3 times here. 4 times. And then this is its last time, so then after that these two will start again. So these two have started again, but then the problem with this is that then after that these two won't start. Because you see that we're just setting this to false, but we're not really setting the vertical axis to true after that. So then that's why we're just gonna go and say data, and we'll just say set vertical axis to true. So now it will just go on forever. This way, that's how it will happen. So this is working. That's good. The animation goes on. But where's the GPIO in here? Where's the Raspberry Pi? Where are all the LEDs? And that is what we're going to make now. So what I have for my west to east LED is that I have the green as GPIO 6. So that's how I did mine as the circuit. So what we will do generally is go to more blocks, say add an extension, and you see Pi GPIO, click on that, and say OK. So this is added. Good. So originally we're gonna set all of them to false, so I'll just set the green LED to true first. Why is this there? Okay, that's fine, we don't need it anymore. Okay, yeah, good. So you'll say set GPIO, and I have GPIO 6 as my green LED, and that's what's supposed to be on first because the west and east will start going first. So I'll say set GPIO 6 to output high. And my red LED has a GPIO 13. It's connected to GPIO 13 as per the circuit. So I'll say set GPIO 13 to output low because these two are going, so they have a green signal. And then after that, again, I'll just inside the repeat. Also, it's supposed to be the same. Again, as you know, they're in the forever loop. So I'll say repeat, set GPIO, and I'll say set GPIO 6 to output high. So we're just doing the same thing here because the whole program is in the forever. That's why. And I'll say set GPIO 13 to output low. So this is output low. Okay, so that's good. And then after that, these two will start gliding. So then they'll get a red signal. So after that, before setting I'll set the horizontal axis to false. But before that, I'm going to set GPIO 13 to output high because then the red LED will be on because they have the red signal. And then I'll say set GPIO 6 to output low. So this is my GPIO program for the west to east LEDs. But what is this? So here, all I'm doing is just turning on the green LED. Here, I'm turning on the green LED. And here, I'm turning off the green LED and I'm turning on the red LED. That's what I'm trying to do. So this is the green signal, red signal. That's what I have here. So it's very simple. And I'm going to implement the same thing. So I have, so first, initially, I'm going to set the red LED as a true because then these two are going to glide first in the program. So I'll say set GPIO 21 because as per my circuit, 21 is the red LED. So I'll keep that output high. And then I'll say set GPIO, and I have 16 as my green LED. So I'll say set GPIO 16 to output low. So this just means that it's the red signal. That's what it means. Inside the repeat, I'm going to turn on the green LED, so it's just the opposite. I'm turning the 21 to output low, and I'm setting GPIO 16 to output high. So GPIO 16. Great. So this, all it means is that the green traffic signal is on. That's what it means. And here, I'm going to say set GPIO. And here, I'm going to say set GPIO 21 to output high. And then here, I'm going to say set GPIO. And I'll say 16 to output low. So all this means is that this is going to be the red signal, this is the green signal, and this is the red signal. So that's what this means basically. And let's just check. We're setting the horizontal axis to false here, but we forgot to set the vertical axis to true. So I'll say set vertical axis to true here. So I kept that. Okay. There, so that's good. And yeah, that's all. So now I'm going to this is what the code has here. Okay, good. And this is the code for the yellow one. Okay, so that's good. Now I'm going to bring in the phone. I'm going to bring in the phone here. So this is the phone. I'll just say always on top. And now let's run it again and see the whole result. So there, these two will start. Okay, so you can currently see that the west and east are going, so that's why they have a green signal. And then north and south are not moving at all, so that's why they have a red signal currently. And this is how it varies, basically. So these two will just keep on gliding for 5 times, as per our program. And then these two will just stop and they won't move at all. So that's what will happen right now. And then later on, now you can see it's vice versa. So since the north and south are moving and they are currently gliding right now because they have a green signal. And now the west and east are not moving at all, which means that they're not gliding because they have a red signal. And henceforth, they're not going to move at all. They're not going to cross. And then as this goes on, these two will stop, and then it will be vice versa, and that's how this whole thing will go. Now you can see it's the opposite. So that's how we'll just go on, basically. So I'll stop this and minimize that. And I'll uncheck this option, always on top. There, good. So this is what we made today, guys. Today we learned about basics of Raspberry Pi, and we also made an LED program about traffic lights. So next video, I'm going to talk to you guys more about DC motors. So till then, see you later.